Welcome to the LPX500 Quick Start Guide. In this video we're going to go through the basic connections for SDI and IP. But first let's go through the front panel. Here we have the power on off switch, the rotary encoder, the USB ports for keyboard, mouse and memory stick, and headphone jack, along with the 8-inch touchscreen display. The LPX500 can come in three main versions, including the LPX500i for IP, the LPX500IS with SDI and IP, and the LPX500ISE with IP, SDI and I on SDI input 1. Let's now go through some of the basic connections on the back of the LPX500. Starting with the 1 gigabit RJ45 management port connection. Connect this into a 1 gigabit switch and use the network and automation tool to configure the IP parameters such as your IP address, default gateway and DNS server. You can also use this tool to enable the VNC server for remote access and REST API. The LPX can be connected to a DisplayPort external monitor or SDI monitor. The use of an active DisplayPort to HDMI adapter is recommended, along with rebooting the unit once the DisplayPort cable has been connected. Using the display settings parameters, you can change the output rate to the frequency of your monitor, as well as the UI brightness control, and enable or disable the pop-up function bar menu. When enabled, hover the mouse at the bottom of the screen to show the pop-up menu. Disabling the function bar pop-up is recommended when using the touchscreen or VNC client. In conjunction with the audio meters instrument, you can control the audio levels using the volume control in the audio settings. Connect an analog reference source such as a black and burst signal or tri-level sync into this port. Open the video timing and system reference instrument. Use this instrument to take different timing measurements such as media latency, external reference against PTP and SDI timing, as well as setting the Genlock source for the generator. Use the USB ports on the back to connect a keyboard, mouse or memory sticks. Then plug in the mains cable into the AC input. There are a total of 8 SDI connections on the back of the unit, 4 of which are for output. These are used by the generator output and the loop output. Use the generator tool to configure the SDI outputs to the standards you require. Open the video generator from the menu and configure the video standard. Select a test pattern and press OK. Select the SDI output assignment to configure whether the BNCs output the generator or loop the SDI input signal to the output. You can copy the generator to all SDI outputs. The generator is a licensable option. SDI inputs 1 to 4 are used by the analyzer instruments to display the incoming signal. Using the analyzer input assignment, you can assign the SDI inputs to each analyzer. The analyzer input assignments can be configured for dual link using inputs 1, 2, or 3 and 4, or as a single quad link input using all 4 inputs. An invalid selection is highlighted in red. The same SDI input can be assigned to multiple analyzers. In this example, SDI input 1 is assigned to analyzer A and B. Next, we'll assign different picture windows to different analyzers. When opening the picture window for the first time, it will automatically be assigned to analyzer A. If you open the picture window again, it will be assigned to analyzer B. The analyzer input can be changed by using the analyzer input menu from the function bar after selecting the picture window. If the analyzer has already been assigned, you will see the analyzer is in use message. Either close the window where the analyzer was previously open, or reassign the analyzer input. The analyzer can also be changed using the analyzer drop-down list from the menu. Note the quad analyzer is an option. The eye and jitter is only available on SDI input 1. The LPX500 supports multiple link rates for IP connectivity. 10 gig connectivity is supported out of the box using the optional SFP plus 10 gig interfaces. 25 gig connectivity is also supported using the optional 25 gig IP license and SFP28. You can receive multiple streams using ST2110 or ST2022-6. 2022-7 seamless switching mode is also supported. You can also receive a single active PTP reference feed into any of the SFP interfaces as the system reference. Note multi-rate SFPs are not supported, and 2022-6 transmit is only supported on SFP2. After plugging in your SFP modules and connecting to your switch, we can then configure the SFP settings. Open SFP1 and SFP2 info to see the SFP information, and open the Net A and Net B stats to see the packets being received and transmitted and the link speed of the SFP. Opening the PTP info tool will allow you to configure and see the PTP information. And lastly, we'll open the Media Network tool in order to configure the SFP IP addresses. The IP addresses are currently assigned dynamically from the DHCP server. You can configure the IP addresses using the IP parameters settings and setting it to static, and then changing the IP address, the gateway and the DNS server. I'm going to leave my settings on dynamic. Next, we need to check the forward error correction mode. My switch ports have been configured for RSFEC, so we need to make sure that our SFPs are also set to RSFEC. And you can also see that my SFPs are 25 gig. We can then check the PTP info tool to see that it's receiving PTP. Open up the configuration and change the domain number to the domain that your PTP is expected to be on. If configured correctly, the PTP should say that it's locked. 100 gig QSFP connections are supported using a software license option and 100 gig QSFP modules when plugged in to QSFP slots 3 and 4. You can receive multiple streams using ST2110 or ST2022-6. 2022-7 seamless switching mode is also supported. You can also receive a single active PTP reference feed into any of the SFP interfaces as the system reference. Note multi-rates QSFPs are not supported, and 2022-6 transmit is only supported on NetB QSFP4. After plugging in your QSFP modules and connecting to your switch, we can then configure the QSFP settings, similar to how we did them in the SFP section. Opening up the QSFP 3 and 4 information tools, we can see that the SFPs are plugged in. Open the NetStats A and B tool to see the packets arriving and the current link speed. Open the PTP info tool to see the PTP information and configuration. And lastly, open the Media Network tool to configure the IP addresses. Currently, you would have noticed that I'm using the SFP28 modules, which are 25 gig. To use the 100 gig QSFP connections, we need to configure the system to use QSFP, using the QSFP or SFP option from the menu. Then we need to check and reconfigure the IP parameters, either setting a static IP address or setting to dynamic if a DHCP server is available on the network. We now need to check the forward error correction mode for the 100 gig interfaces. In my case, RSFEC mode is enabled on the switch port, so I need to configure each QSFP module to have RSFEC enabled. We can then check the PTP info tool to see that it's receiving PTP. Open up the configuration and change the domain number to the domain that your PTP is expected to be on. You can also use the System I/O tool to check the QSFP or SFP connections. You can also use the tool to configure whether you're using the QSFPs or SFPs by touching the icons on the screen or from the System I/O menu. Now that we have set up the IP connections, we can move on to setting up the IP flows. Select the IP receive flows window from the Instruments menu, and then open up the menu and select Multicast Flow Config. Select the network interface and type in the multicast address for the flow you wish to configure. Here I'm setting up to receive a 2110-20 video flow. press the Join button to join the multicast request. Then select the Flow Config window and select the flow. Now configure the protocol and press Add after configuring the parameters for the flow. Next, I'm going to configure the 2110-30 audio flow using the same steps as I did for the 2110-20 flow. Once you have finished setting up your flows, select OK to go back to the IP Flows window. Select IP Flows Group Config from the menu or from the function bar. Here we can assign the individual flows to the IP flow groups. The -20 and -30 flows are assigned to IP1. The IP flow group has not yet been assigned to an analyzer. Open up the settings and go to the Analyzer Input Assignment and assign Analyzer A to IP flow group IP1. Now go to the Instruments menu and open up any of the analyzers to analyze the flow. Here I've chosen the picture window, the packet interval timing window, and the 2110 format setup window. The 2110 format setup window may be required to override the format parameters. Note that the same flow cannot be assigned to multiple flow groups. Now I'm going to move the flows onto IP flow group 2 Analyzer B. First of all, deselect the flows on IP flow group 1 and then select IP flow group 2 and reselect the flows. Now assign Analyzer B to IP flow group 2. And now reassign the analyzer windows to Analyzer B flow group 2. If the format cannot be estimated correctly from the RTP stream or an STP is not provided, then you can override the format parameters to make the analyzers stable. If you have the generator option, we can also generate and transmit 2110 or 2022-6 flows. Here we'll generate 2110. Open the Generator tool from the Instruments menu and the 2110 Transmit tool, and also open the System Timing and Reference tool. Currently the LPX500 is locked to free run. We need to set this to be PTP when generating 2110. Open up the menu on the System Timing Reference tool and select PTP from the options. The displays may go black momentarily while the unit resyncs. Now select the generator and open up the menu. Select Video Generator and switch the output to 2110. You can also change the video standard settings and select a user test pattern. When configured, select OK. Now we need to set up the 2110 Transmit tool to configure the flows that we wish to transmit. Select Configure TX Flows from the menu and then select the video, audio, ancillary flows that you wish to configure. Configure the flows interfaces and multicast IP addresses and any other parameters dedicated to that flow. And then select OK. Configure the audio and ancillary flows in much the same way. When finished configuring your flows, press Apply and OK to exit out of the configuration tool. The 2110 Transmit tool will then display the flows set up, the IP addresses, and the bandwidth being sent out. The flows are now ready to be received by the devices on your network. The extended monitor provides a second, independent touchscreen with most of the capabilities of the main unit. The extended monitor is an optional extra. Connect the supplied high-speed USB-C cable from the back of the extended monitor to the extended monitor USB-C port on the back of the LPX500. Connect the extended monitor before turning on the power. A software license option is also required. Place the extended monitor to the left-hand side of the main unit, looking from the front, or use the optional rack mount kit. When the unit is turned on, the main UI will show on both the main unit and the extended monitor. The extended monitor UI will look much the same as on the main unit, apart from a few things in the settings menu which won't be available, such as the file manager and the clock settings. I'm now going to go through and configure 4 analyzers across both screens. Using the Favorites toolbar, I'm going to open up the picture window on Analyzer A and B on the extended monitor, and the picture window on Analyzer C and D on the main unit. Note that you need to reassign the analyzers when working across both screens. The first picture window is currently assigned to the IP flow group. I'm just going to switch this to be SDI. And now I'm going to change the analyzer assignment for the third and fourth window on the main unit to analyzers C and D. And now I'm going to open up the waveform instrument on the extended display and then on the main display. And as we did with the picture window, I'm going to have to reassign the third and fourth waveform monitor to analyzers C and D, as analyzers A and B are already assigned on the extended monitor. You can move the windows into any position and resize them down to 1/16 size, leave them at 1/4 or full screen. Thank you for watching this quick start guide for the LPX500.